The learning objective of this chapter is to become familiar with the origins of the international agreements on maritime trade, the role of the IMO, the International Maritime Organization, SOLAS 74 and MARPOL 73-78. In April 1912, the liner Titanic struck an iceberg and sank. More than 1,500 passengers and crew died. The following year, an international conference was held in London, and in 1914, the first International Convention for the Safety of Life at Sea, or SOLAS, was adopted and signed by representatives of the world's leading maritime nations. It included regulations on navigation, ship construction, life-saving appliances, and emergency communications. One basic problem was that there was no international organization which could coordinate and monitor the measures drawn up by these conventions. An example relevant to this program was that the labels identifying and categorizing dangerous goods differed from country to country. The formation of the United Nations Organization provided the opportunity for creating just such a specialized marine agency, and the resulting Intergovernmental Maritime Consultative Organization, or IMCO, came into being in 1959. The new organization drew up a new version of the International Convention for the Safety of Life at Sea, the most important of all treaties dealing with maritime safety, and then turned its attention to the carriage of dangerous goods, producing the first edition of the International Maritime Dangerous Goods Code in 1965. In 1982, the IMCO changed its name to the International Maritime Organization, or, as it is more commonly referred to, the IMO. The IMO is responsible for keeping a number of codes dealing with dangerous goods up to date. These include the IMDG code, the BC code, or Code of Safe Practice for Solid Bulk Cargoes, the IBC code, or International Code for the Construction and Equipment of Ships Carrying Dangerous Chemicals in Bulk, for ships constructed after the 1st of July 1986. The IGC Code, or International Code for the Construction and Equipment of Ships Carrying Liquefied Gases in Bulk, for ships constructed after the 1st of July 1986. The International Convention for the Safety of Life at Sea, 1974, is the current SOLAS Convention, and came into force in 1980. A series of amendments also applies. Chapter 7 of SOLAS 74 covers the carriage of dangerous goods by sea. The International Convention for the Prevention of Pollution from Ships was passed by the IMO in 1973 and modified by the Protocol of 1978. The Convention and the Protocol are known as MARPOL 73-78. A series of amendments also applies. Annex 3 of MARPOL 73-78 deals with the prevention of pollution by harmful substances carried by sea in packaged form. In 1985, Annex 3 was aligned with the IMDG code, thereby introducing the implications of marine pollution to the carriage of dangerous goods. The relevant sections in the SOLAS and MARPOL conventions concerned with the carriage of dangerous goods by sea lay down the guidelines, and the IMO, through its committee structure, produces the detailed provisions and codes of practice. The IMDG code includes a section on training for shore-based personnel. Many of the specific procedures discussed in this program will already have been addressed when a package containing dangerous goods is loaded on board a ship, but an understanding of the IMDG code is important for all who come into contact with that package. The IMDG code has a section on security, but we must also refer to the International Ship and Port Facility Security Code, generally referred to as the ISPS code, for such guidance. The learning objective of this chapter is to examine the contents of the IMDG code and its supplement, leading to an understanding of their application. Note: this module is based on the IMDG Code 2004 edition, International Maritime Dangerous Goods Code, incorporating Amendment 3204 and the 2004 supplement. Where the phrase "the code" is used in this module, it refers to this code. The IMDG code is an international agreement for the transport of dangerous goods by sea. It is published by the IMO. Many sections of the code apply more to those who work ashore in documenting, packaging and handling dangerous goods, or in the manufacture of packaging. The ship's senior officers and shoreside management staff will also need to know about and use the code a lot more than you will be required to do. In most situations, you will be following instructions for loading or discharging your ship, and all of the planning and documentation will have been done by the officers and shore staff. However, a basic knowledge of the contents and provisions of all areas of the code will ensure that all seafarers are better able to perform their own duties. It is also important to point out that the majority of problems with dangerous cargo consignments are not the fault of the ship's personnel in any way. Problem shipments are, however, intercepted at the point of loading by vigilant staff, and a good reporting procedure between crew and the responsible officers is essential. Make sure you follow this instruction. If you see something you are not sure about, report it. The IMDG code comprises 2 volumes and a supplement as shown. Volume 2 contains the following. The supplement contains the following. Volume 1 contains the following. Volume 2 contains the following. The supplement contains the following. The IMDG code is also available as a fully searchable database on CD-ROM, and both intranet and internet versions are available through subscription. The most used part of the code is the dangerous goods list, found in Chapter 3.2 in Volume 2. You will not normally be required to work with this list. The ship's senior officers and the shore team will handle the necessary paperwork, often on computer, but this chapter will help you understand what is involved. Dangerous goods are listed here in numerical order, according to their unique 4-digit United Nations numbers. If you only have the name of the substance, start by looking up the UN number in the index at the back of Volume 2, and then enter the list. The dangerous goods list is divided into 18 columns, which contain references to additional instructions elsewhere in the code. This is the unique identifying number assigned to a dangerous substance, material, or article. This shows the official or proper shipping name of a dangerous substance, material, or article to be used in any documentation relating to transportation. Substances are divided into groups according to their type, and these are called classes. Some are further categorized into divisions. This column indicates the class of the substance, material, or article. This column indicates if there are any additional risks associated with the substance, and also identifies those dangerous goods considered to be marine pollutants or severe marine pollutants by using the following codes. For packing purposes, substances or articles of certain groups have been divided into three categories, or packaging groups, according to the degree of danger they present: high danger, Group 1, medium danger, Group 2, and low danger, Group 3. This column contains a number referring to any special provisions relevant to the substance or article. Different rules apply to the transport of dangerous goods of certain classes, where there is only a limited quantity. The maximum quantity per inner packing, under which the provisions of this chapter apply, is indicated in this column. Different rules apply to the transport of dangerous goods of certain classes, where there is only a limited quantity. The maximum quantity per inner packing, under which the provisions of this chapter apply, is indicated in this column. This column contains a letter number code which refers to a detailed list of instructions concerning the use of packagings. This column contains a similar letter number code which refers to certain special packing provisions. This column shows codes that refer to instructions concerning the use of intermediate bulk containers. This column contains codes which refer to special packing provisions applicable to IBCs. This column only applies to older portable tanks and road tank vehicles, some of which may still be in service. This column applies to more modern portable tanks and road tank vehicles. This column contains codes referring to special provisions for the transport of dangerous goods in portable tanks and road tank vehicles. The entries in this column refer to the relevant emergency instructions for fire and spillage, which are found in the EMS Guide Emergency Response Procedures for Ships Carrying Dangerous Goods in the supplement. This column shows requirements for the stowage and segregation of the different packages. This column contains further special information on the chemical properties of dangerous goods listed. This is simply a repeat of the unique identifying number, as also shown in column 1, to assist in tracing information across the two adjacent pages. The index found at the back of Volume 2 contains an alphabetical listing of all commonly shipped substances, materials, and articles. In this index, if the word C appears after the name in the substance, material, or article column, this indicates the entry as a synonym, and reference must be made to the entry in the dangerous goods list, against the UN number and proper shipping name shown. 3 columns appear alongside the names, indicating marine pollutants, class, and UN number for ready reference to the most commonly required items. Some substances, materials, or articles are not mentioned specifically by name in the dangerous goods list. These are referred to as generic or not otherwise specified cargoes and are listed in Appendix A to the Code. The learning objective of this chapter is to examine some basic chemical terms found in the IMDG code. A number of basic chemical terms are used in the IMDG code. Material is a non-specific term, usually applied in a collective sense, such as raw materials. Any kind of matter. An article is a device that contains a dangerous substance or mixture of substances. a sample of two or more substances, each of which retains its individual chemical identity and physical properties. Matter exists in three main states for our purposes here: solid, liquid, or gas. The physical state of many substances will vary depending upon the temperature and pressure applied to them. A solid is matter in its most concentrated form, normally a closely packed and regular crystalline structure, thus making it difficult to compress. Solids hold their shape. They can generally be melted by heat, although the level required may be extremely high, and a few solids convert to gas directly through a process known as sublimation. Some solids take water from the air and become damp. A liquid is a non-crystalline form of matter, falling between the solid and gaseous states. Liquids have definite mass and are difficult to compress. They have no permanent shape, and the molecules are free to move within the limits of any container. When molecules escape from the liquid surface into an unrestricted atmosphere above, this is called evaporation. Liquids vary greatly in viscosity, melting point, vapor pressure, and surface tension. Compare, for example, molasses to water. Gas is a state of matter characterized by very low density and viscosity when compared to liquids and solids. Gases have definite mass, but will readily expand or contract under changes in applied heat or pressure. Some gases, like chlorine, are heavier than air, while others, like hydrogen, are lighter. Gases mix easily and will fill any space uniformly and completely with time. They are easily compressed and are transported in pressure-resistant gas cylinders. Chemicals are identified and characterized by their properties. Physical properties are used to assist in the classification of substances and articles within the code, and some important physical properties are also specified in the code on the individual schedules. The physical properties we are concerned with are listed below. Click on the properties to get more information. Flash point is the lowest temperature at which a liquid or volatile solid gives off sufficient vapors to form an ignitable mixture with the air near its surface. A flammable liquid cannot be ignited so long as its temperature remains below the flash point. The flash point gives an indication of the risk of formation of an explosive or ignitable mixture when a liquid escapes from its packaging. Note: tests such as for flash point should never be carried out on board. They are only to be done in appointed laboratories under controlled conditions. This is the range of concentration of a flammable gas or vapor in which explosion can occur upon ignition in a confined area. In other words, it is the percentage by volume of the vapor-air mixture in which a flash will occur, or a flame will travel if the mixture is ignited. Below the lower explosive limit, the mixture is termed too lean, containing insufficient combustible fuel to sustain ignition. Above the upper explosive limit, the mixture is termed too rich, containing insufficient oxygen to sustain ignition. The melting point is the temperature at which a solid will change into a liquid at atmospheric pressure when heated, such as ice turning to water. Note, the terms melting point and freezing point are often used interchangeably, depending on whether the substance is being heated or cooled. Care must be exercised in the selection of packing materials for solids which have a relatively low melting point, when, for example, transporting them from cold northern areas to a tropical region. Solubility is the ability or tendency of one substance to blend uniformly with another, such as a solid in a liquid. The term miscibility is often applied to one liquid dissolving in another liquid, or one gas in another gas. Solubility is generally expressed in percentage, although generic terms such as completely, freely, or partially are also used. Miscibility and relative density are important factors in assessing the medium to be used in fighting fires involving chemicals. For example, water would not be suitable for fighting fires involving petrol, which would float on the water and spread the fire. Odor is another name for smell. Many substances have a characteristic odor, which may be the first indication of product escape, and any unusual or unexpected odor should be treated as a warning, triggering an appropriate emergency response. Be aware, however, that certain substances have no discernible odor, and sensitive instruments will be required to detect their presence. A substance capable of being readily ignited and burning. The terms flammable and inflammable are interchangeable in the context of the IMDG code. The learning objectives of this chapter are to give those personnel involved in handling dangerous goods an understanding of the criteria used to determine whether goods should be considered as dangerous, and a working knowledge of the 9 classes and their respective divisions to which dangerous goods are assigned. The classification is described in Chapter 2, contained in Volume 1 of the IMDG Code. All chemicals are to greater or lesser extent hazardous to human health or to the environment. While a chemical liquid may not necessarily damage the skin on contact, it could be dangerous if consumed. The hazard posed arises from either the substance or article itself, often caused by a change in its storage or transport condition, or by reaction of the substance or article with other substances in the immediate surrounding area. It is very important, therefore, that those responsible for stowing cargo in a ship fully understand the risks involved with every package of dangerous cargo, and that you follow any instructions about safe stowage fully. For safe handling, the UN has divided hazardous substances and articles into 9 classes, based on the type of hazard that they present. The purpose of classification is to divide dangerous goods into broad groups having the same properties. The potential for harm to personnel, the environment, or equipment has been assessed in terms of reactivity, flammability, toxicity, and corrosiveness. There are 9 classes, some of which have been further sorted into subgroups called divisions. Note that the order of the class numbers does not indicate the degree of danger, but only the type of hazard. The classes are explosives, gases, flammable liquids, flammable solids, substances liable to spontaneous combustion, substances which in contact with water emit flammable gases, oxidizing substances and organic peroxides, toxic and infectious substances, radioactive material, corrosive substances, miscellaneous dangerous substances and articles. Chemical explosions are usually caused by very rapid burning of a substance or mixture of substances in the presence of oxygen in the air. Goods of Class 1 are described as compatible if they can be safely stowed or transported together without significantly increasing the chance of an accident. With this in mind, goods listed in this class are stowed according to a special table which ensures adequate distance between respective packages. Gases may be either compressed, liquefied, or refrigerated liquefied. Class 2 substances are grouped according to the primary hazard of the gas during transport, namely Class 3 includes Class 4 comprises of substances, except those classified as explosives, which readily catch on fire or may cause or contribute to a fire. There are 3 groups. Class 5 comprises of 2 groups. Class 6 deals with toxic and infectious substances and is made up of 2 groups. Class 7. All radioactive materials are dangerous to a greater or lesser degree because they emit radiation, which is invisible and may damage body tissue. The carriage of radioactive materials involves special procedures and equipment, and those involved in handling radioactive materials receive specialist training. Class 8. Corrosive substances are those substances which by chemical reaction will cause severe damage when in contact with living tissue, or, in the case of leakage, will materially damage or even destroy other cargoes or the framework of the ship. Class 9 covers substances and articles which present a danger not covered by other classes in the Code. A marine pollutant is a substance which, because of its potential to damage seafood or to poison other aquatic life, is subject to the provisions of MARPOL and carried by sea accordingly. Substances of all classes may be classified as marine pollutants. A distinction is made between substances which have a pollution potential, indicating them as marine pollutants, and those which have an extreme pollution potential, indicating them as severe marine pollutants.